All right, welcome back to another episode of Science with Surbeck. Today what we're going to be talking about is section 12.4, which deals with the percent yield. Now before we get going into the video, there's a couple of objectives I have for you, and you should be able to accomplish these objectives by the end of this video. So objective number 1, calculate the theoretical yield of a chemical reaction from data. And objective number 2, determine the percent yield for a chemical reaction. So we start out here with a few terms and definitions, and this first term that we start out with is the theoretical yield. Now, the theoretical yield is defined as the maximum amount of product that can be produced from a given amount of reactants. Now, in the stoichiometric problems that you have done up to this point, you have actually calculated the theoretical yield of products. Now, it's important to note that you rarely in a chemical reaction produce the theoretical yield of a particular product. And you may be wondering, okay, well, why would there not be the theoretical yield produced? Well, here are some reasons. So reason number 1 is many reactions stop before all the reactants are used up. So what actually happens is the actual amount of product is less than expected. Another reason is that liquid reactants or products may adhere to the surface of the container in which they are in, or they may evaporate. And this solid product or a solid product is always left behind on filter paper lost in purification process. And then another reason is that products that aren't expected or aren't intended to be in the reaction are actually produced. So it's almost like a side effect or a side reaction that happens as a consequence of running the reaction that we are looking at. Now, this can all be summed up by one general word, and that is lab error. Okay? So something went wrong in the reaction, and that's why we do not produce that theoretical yield. Rarely do we ever get to have a yield that is a theoretical yield or matches that theoretical yield. Now, I've thrown out some other terms here while I was explaining this, and that other term is the actual yield. So the actual yield is defined as the amount of product actually produced when the chemical reaction is carried out in an experiment. Now, in the lab, a chemist is going to determine the actual yield of a reaction through careful experiments in which the mass of the product is measured. So now we can move on to another term and definition that we need to know, and that is the percent yield. And so the percent yield is defined as the ratio of the actual yield to the theoretical yield expressed as a percent. Now that definition is fine and dandy, but there's a formula that is associated with this exact definition. And so the formula of the percent yield is as follows. We have the percent yield is equal to the actual yield divided by the theoretical yield and then we have to multiply all of this business here by 100 to get us into percents. Now I want to make one quick note here, and that is this. The actual yield is obtained through an experiment. So we actually are in the lab and we get this value here of the actual yield from the data that we collect in a lab experiment. What we can do with this is we can know how efficient a reaction is in producing a desired product. Okay, so we've gone over the three main definitions of this sections, and now we can put these to the test when we talk about the steps of how to actually calculate the percent yield. Remember, we will actually need to obtain the actual and the theoretical yield to be able to find that percent yield. So let's go through this and let's go through the steps of how to calculate the percent yield. So the first step to calculate the percent yield is balance the chemical equation. The second step is to determine the theoretical yield. Now within step 2, there are a series of sub-steps. The first sub-step is to convert grams of a given substance to moles of that given substance. The next process here is to use the mole ratio to convert from moles of our given substance to moles of our desired product. Now the last step in or embedded within step 2 is to convert the moles of the desired product to grams of desired product. Now once you convert to grams of your desired product, that is your theoretical yield. Now the third step in finding or calculating the percent yield is to divide the actual yield by the theoretical yield and multiply by 100. Now, the actual yield that we have will be given in problems. In the lab experiments, the actual yield is something that you need to obtain through data. But, of course, since we're not doing a lab experiment on each individual problem, we will have to be given this set of information. Okay, so let's put these steps to the test, and let's go through an example problem. Okay, so we want to determine the percent yield of the following reaction. We have potassium chromate is added to a solution containing 0.5 grams of silver nitrate. As the products produced, there's solid silver chromate and there is potassium nitrate formed. We want to determine the theoretical yield of the silver chromate precipitate. If 0.455 grams of silver chromate is obtained, what is the percent yield? So everything is outlined here, and now we can walk through those steps that we just went through. So the first thing is to balance our chemical equation. So we look here, we have 2 K's on the left. Over here on the right, we only have 1. So that means we need a coefficient of 2. And then we look to our Cr, we have 1 chromium on our left. Cr on the right, we have 1, so that is balanced. And then we move to our oxygens. And I'm going to skip oxygen for a second. I'm going to move to silver. Silver on the left has 1. Silver on the right has 2. So that means to make this a 2, we put a 2 out in front. And that will make our oxygens nice here. So oxygens, we have 4 from the first substance or the first reactant, plus 2 times 3, 6. So we have 4 plus 6, a total of 10 oxygens. Over here on the right, we have 4 plus 2 times 3, so 4 plus 6, which is 10. So at this point in time, our equation is balanced. Now what we need to do is we need to go through these steps, and we need to be able to determine what is our theoretical yield of silver chromate. Now, to do this, we're going to need some molar masses of silver nitrate and silver chromate. So I went ahead, I calculated these values, and for silver nitrate, the molar mass is 169.81 grams per mole. And for silver chromate, the molar mass is 331.6 grams per mole. Okay, those are very important that we use here. So now, we start out with 0.500 grams of silver nitrate. So this right here, 0.500 grams of silver nitrate, that is our starting substance. So we start out here with 0.500 grams of our silver nitrate. And what we're going to do, we are going to convert it eventually to grams of silver chromate. Now, this type of conversion is a 3-step conversion, so there'll be 3 different conversions that we need to go through. So we set up our conversion factor, and remember, diagonal units always cancel out. So we're going to cancel out grams of AgNO3. And we always need to, a good rule of thumb is we always need to go from grams of that substance to moles of that same substance. So moles of AgNO3. And now, whenever you have mole over gram or gram over mole, you turn to the molar mass, which I gave you, of silver nitrate. Now, the 169.81 number is associated with grams. So that means on bottom here, I'm going to put 169.81 grams for every 1 mole. Now, I do my second conversion. And again, I always want to cancel out diagonal units. So I have moles of AgNO3. And now, because I'm in moles, I can go from moles of one substance to moles of another. Again, has to be mole to mole, but this allows me to convert to my silver chromate, or Ag2CrO4. So we have Ag2CrO4. And now, mole over mole, we turn to our balanced chemical equation. So right here, in front of AgNO3, I have a coefficient of 2. That means in my mole to mole ratio with AgNO3, I put a 2 because it matches that balanced chemical equation coefficient of 2. Now, over here for Ag2CrO4, the coefficient is 1. So that means in my ratio, I put a coefficient of 1. Now, we're not quite done because we need grams of our silver chromate. So again, we go one further step here, and we want to cancel out moles of silver chromate. So moles of Ag2CrO4. And on top, we want to put our grams of Ag2CrO4. Now, gram over mole, we turn to the molar mass of silver chromate, which is 331.6 grams per mole. This means this 331 number is associated with grams. It goes on top in this case. So we put 331.6 grams for every 1 mole. All right, so now we can calculate. All right, so what I'm going to do, I'm going to take everything multiplied across the top. So I'm going to take 0.500 times 1 times 1 times 331.6, and then I'm going to divide it by everything on bottom. So I'm going to take 0.500 times 1 times 1 times 331.6. I press enter. And then I'm going to divide it by everything on bottom. Now, I need to start out with a set of parentheses. So on bottom, I have 169.81 times 2 times 1. I close my parentheses, and I press enter. Now, I obtain, I'm going to round this to 3 decimals here, or 3 significant digits. I obtain 0.488 grams of silver chromate. Now, this is really important. This value that we just took the time to calculate, this is our theoretical yield. And what we need to do now is we need to find the percent yield. So as a reminder, I'm going to use the percent symbol. So percent yield is equal to our actual yield divided by our theoretical yield. All times 100 to get us into a percent. So all I'm going to do is I'm going to plug these numbers in. Again, we don't know the percent yield, so we are going to find it in the actual yield. Now, in a real-life lab experiment, this would be tabulated from your data. However, it is given. So in our problem, if we read carefully, it said our 0.455 grams of silver chromate is obtained. This value right here is your actual yield. And so what we do here is this. We are going to put that value of 0.455 into our formula. So this is going to be 0.455 grams, all divided by your theoretical yield, which is 0.488 grams times 100. Okay, so in my calculator, I'm going to take 0.455 divided by 0.488. I'm going to press enter. Now, I get a decimal. We can't forget about multiplying by 100, so I multiply by 100. I press enter. And to 3 total digits, I get a percent yield of 93.2%. So my percent yield for this particular problem is 93.2%. And that right there becomes my answer to this question. So remember, stoichiometry is key. Going through this process, making sure you cancel out diagonally and getting and obtaining the correct theoretical yield will lead to success on these types of problems. All right, we have one more thing that talks about, well, why do we even have these percent yields and what could it be used for? Okay, so percent yields, why do we use them and why do we have them? So number one, if we're thinking big scales like manufacturers are going to reduce the cost of making their products to the lowest level possible. That makes it cheaper for us when we go to the store to buy certain substances. And so if a company does this, they reduce their cost, their chemical cost to the lowest possible amount, it's going to make it cheaper for us to buy these products at the store. And then two, it's going to increase the profit for a company. So tying this business aspect into what we're just talking about shows the significance, the financial significance for both you and me, and also for these companies. So it's helping everybody out to know, okay, if I'm able to have the best percent yield, then maybe I can make more money, maybe there's more profit, more jobs. This is all tied to the economy here. Now, we have to remember too that percent yield is important in the calculations of the overall cost effectiveness of industrial processes. Now, one example of this utilizing percent yield is the making of sulfuric acid. Now, what happens here in the production of sulfuric acid? It's actually a multi-step process, and what happens here is they have to be really aware of what their percent yield is, because depending on the percent yield will ultimately dictate how much profit they have. Now, just to add this here, sulfuric acid is used in a lot of fertilizers. And so what that means for us is if it's used in agriculture, it's going to drive the price of food. Everything from your corn and your beans and anything in the field to anything that eats that food, which is animals and humans and so on and so forth. So we could tie in the food chain here. So it's really important here that companies evaluate their percent yield to be able to calculate what steps they need to take next in the production of the substances that are utilized on things we need, such as crops or agriculture products. So it really has limitless possibilities here of how we can use this percent yield. All right, so we've talked about a lot. We've kind of tied all ends together with our chapter 12 and our business on stoichiometry. And we have now completed chapter 12 and obviously this section. So I hope you have enjoyed this video. And as always, if you haven't already, make sure you subscribe.